When you look up into the night sky, do you wonder about its mysteries? Well, I invite you to imagine a world where the fabric of reality is not what it seems. A reality where the stars and galaxies that you see in the night sky are not the only thing shaping the universe. There seems to be hidden forces at play, things so mysterious that they remain unseen and undetectable. In this two-part series, we'll be explaining the forces that exist beyond our reach and beyond our sight, invisible forces that make up most of our universe and are considered the greatest mysteries of science: dark matter and dark energy. In the early 20th century, Fritz Zwicky, considered one of the most brilliant and unconventional astronomers, discovered something strange while studying a cluster of galaxies. He observed that the movement of these galaxies were not operating as expected based on the amount of visible matter present in the cluster. The galaxies were moving too quickly and were not bound together by the gravitational force of the visible matter. This led to the conclusion that there must be a significant amount of unseen or dark matter in the cluster, giving the additional gravitational pull needed to keep the galaxies together. He named this mysterious substance dark matter and proposed its existence in 1933. At the time, Zwicky's discoveries of this missing mass was unexpected and challenged traditional understanding of the presence of matter in the universe. The idea that there was a significant amount of this dark matter in the universe was met with skepticism by many in the scientific community, who believed that there was a miscalculation in the observed motion of galaxies, which could be explained by alternative theories. Some skeptics proposed that the missing mass in galaxy clusters could be explained by the presence of large amounts of normal matter, such as brown dwarfs or low-mass stars, that is not visible to telescopes. Some skeptics believed that the mass of the galaxies themselves was being overestimated, and that the observed movements could be explained by the presence of less missing mass than was originally thought. These alternative theories were proven to be wrong because they were unable to explain a number of observed phenomena in the universe, such as large-scale structure of the universe, the cosmic microwave background radiation, and the motions of galaxies observed by this visionary astronomer. Despite the pushback, Zwicky's ideas were ahead of their time, and it wasn't until decades later that other astronomers confirmed his theory through bodies of evidence that led the majority of the scientific community to accept the idea of dark matter as the most likely explanation for the discrepancies in the motions of galaxies and the missing mass in galaxy clusters. How do we begin to define dark matter, and how does it differ from normal matter? Unlike normal matter, such as all that we see or feel, this elusive force, dark matter, doesn't interact with light or other forms of electromagnetic radiation, and doesn't appear to interact with normal matter through any of the known fundamental forces except for gravity. We can define dark matter as an invisible, mysterious substance that makes up most of the universe's mass and is responsible for its structure formation. It explains the gravitational effects observed in the universe that cannot be accounted for by the visible matter alone, and reveals that what we see and observe with telescopes is only a small fraction of what actually exists. In the context of the Big Bang Theory, this exotic material is thought to have played a crucial role in the early universe, helping to provide the seeds for the growth of structures like galaxies, such as our galaxy, the Milky Way. It's estimated that this dark material constitutes about 27% of the total matter-energy content of the universe, whereas visible matter, such as air, stars, planets, gas, and anything that you can think of, including us, only constitutes 5% of the universe. Scientists determine the amount of this by studying its gravitational effects on detectable matter through cosmological simulations. Beyond our reach and beyond our sight, there's still a question that remains. If this elusive and mysterious force makes up 27% of our universe, and we make up 5% of our universe, then what dominant forces make up the rest?